Okay, so we have talked about specific heat capacity, and now we've talked about latent heat. Okay, so there's two different latent heats: vaporization and fusion, depending on whether you're going from a solid to a liquid or a liquid to a gas, or the opposite way around. Okay, so we looked last lesson at latent heat, and we said that was EH equals mL, and you use that when there's a change in state. And the specific heat capacity we just went through in homework is when there's a change in temperature. So this is going to take into account both things happening. So we're going to be using both equations in this one. So example 1. A 1.2 kilogram tub of ice cream is removed from a freezer at a temperature of minus 5 degrees C. Ava, you just asked me something. So changing temperature is when it changes temperature. So it goes from like 20 degrees C to 100 degrees C. Yes. Yeah. And changing state is if it goes from a solid to a liquid or a liquid to a gas. And that's EH equals mL. Yeah. But it doesn't happen very often. Yeah, exactly. Sublimation. Anybody happy? Okay. Right. Okay. So it comes out of the freezer and it's minus 5 degrees C. Its temperature rises to 0 degrees C. So we've got a change in temperature. And then it melts. So then we've got a change in state. Its temperature then rises again to room temperature. So we've got a change in temperature, change in state, change in temperature. So we have to really split this up into 3 different parts, because we want to find the heat energy taken in by the ice cream from the time it's removed from the freezer until it reaches room temperature. And we've been given the specific heat capacity of frozen ice cream, specific heat capacity of melted ice cream, and the specific latent heat of fusion of ice cream. So that's from when it goes from a solid to a liquid. Right, so what I'm going to do is I'm going to put it under 3 headings. So first of all, from minus 5 degrees C to 0 degrees C. So we've got a change in temperature. Okay, and as Ava very rightly pointed out, when we've got a change in temperature, we use this equation, Cm delta T, because it's got that delta T in it, that change in temperature. So it's frozen ice cream, because it's just been taken out of the freezer. So we use a specific heat capacity of frozen ice cream, which is 2.6 times 10 to the 3. Its mass won't change. Its mass will just be 1.2 kilograms, whether it's liquid or solid. And the change in temperature, it goes from minus 5 to 0. So what is the change in temperature? Thank you. So, I mean, if you've got a question, then other people will have as well. All right, okay. Okay. Listen. So the answer to that is 15,600 joules. So that's 1 point. Then it melts. So yeah, it's removed, it goes from minus 5 to 0, and then it melts. So the energy it takes in when it melts, sorry, go ahead. It would probably be 5 marks, because you've got EH equals Cm delta T, EH equals mL, so 2 marks for the equations, then 2 marks for the answers, and then 1 mark for adding them all together, probably. Right, so melting, we have to use this equation, EH equals mL, because it's a change of state. So the mass is 1.2, And the latent heat of fusion of my screen, because it's solid to liquid, is 3.2 times 10 to the 5. And that comes to 384,000 joules. Okay, so we've got to the fact we've got apathy, it's got to 0 degrees C, it's melted, and then it goes from 0 degrees C to room temperature of 20 degrees C. So we've got another step. Yeah. So from the next one, it's a change in temperature again. So we're going back to EH equals Cm delta T. But we have to use the specific heat capacity of melted ice cream this time, so it's different. It's 4.0 times 10 to the 3. Times by the mass, which is still 1.2, times by the change in temperature, which is 20. And that comes to 96,000 joules. And then to find the total energy, you add the 3 of them up. So total energy equals, 15,600 plus 384,000 plus 96,000, which comes to 495,600 joules. That's your final